in this episode of sort of the IBIS live stream, we're going to talk about ibis.connect, which is a way to unify a bunch of the connection handling from the various inputs, various databases that IBIS can connect to. So I'm in IPython right now. I'm going to import ibis and talk a little bit about what's going on with ibis.connect. And so there's sort of all these different, ways to connect. We have a pattern right now, which is sort of like ibis, backend.connect, and of course, there's, if we look at ClickHouse, you kind of have to know something about the parameters of what you're, gonna connect to. It's like, okay, well, you also have to know that, okay, ibis implements connect using do connect, right? So we've got host and port and database and user password, which are mostly generalizable to the rest of the backends that ibis, handles or interacts with. But then we've got some backend specific ones like client name and compression, and in this case we accept kwargs in case you need to pass something else that ibis like hasn't explicitly encoded anywhere. And then there's kind of the same pattern for Postgres, right? But we've got host, user, password, port, database, and then URL, which is sort of like an alternate way of expressing host, user, password, port, and then driver, of course, which is something specific to SQL Alchemy. And so basically we've wrapped a lot of this connection parameter stuff up in a familiar URL syntax and put it in a single function that handles kind of the dispatching for all the different backends. And this episode is about how to use it. And you'll notice that I'm kind of connecting to like 7 or 8 different backends, and like the way I'm doing this is through our test setup Docker Compose file, which will kind of launch a bunch of services for the backends that sort of require this. And I've already done that in the background before I started this episode, and so I'm probably going to do another stream on how to work with the test suite, in which I'll go over in more detail what's happening with our Docker Compose setup. So let's just see what constructing or connecting to a database using connect looks like. So you can already see I've been testing, of course, the examples, and so let's just build this up from scratch. So the first thing that you write is the name of the backend, ://, and then you can write sort of user, password, at, host name, port. And most of these are optional. It sort of depends on which thing you're dealing with. And then / followed by a database. This is also optional. Most databases have a default database that they point to. And since I'm using our test database, and we call that ibis testing, that's what I'm going to be connecting to. So for ClickHouse, it's running on localhost because it's exposing a port through the container, port 9000, and then I'm going to delete hostname and port because basically the library will use the default implementation. And now I've got a ClickHouse thing that's telling me the database doesn't exist, which that's basically fine. I mean, I haven't actually created the database yet, but we have sort of a thing. I've already imported ibis that we can execute at least something against. Okay, maybe not. Let's see if we can get rid of this and cool. So I didn't give it a database, so it connected to the default database. And that's because I haven't actually run the tests which create the database. The next example I'm going to show is connecting to a database that isn't a server-based database, DuckDB. So the way this works is that since there's no sensible way using sort of plain vanilla DuckDB to it doesn't mean anything to give it a user and a password and all this stuff. IBIS will interpret DuckDB URIs as paths. If there's 3 slashes, it's absolute. Otherwise, it's going to be a relative path. So we can say IBIS testing data or CI/IBIS testing data. We can say IBIS testing at DDB. It's possible there's not actually anything in here, but of course we can do the same kind of execute one. And of course, you can use show SQL and look at you know, dialect, equals duckdb. Hopefully that works. Okay, so it's basically compiling that SQL and showing it to me. So that's how the file-based backends work. And of course, we've got Impala working as well. We can do that. Hopefully there's something there. Okay, there's nothing there. Of course, we can then, execute one again. We can do MySQL similarly. Okay. Again, we don't have any test data in here because we haven't actually run any of the tests yet. So that's MySQL. We've got Postgres. Let's see if this has anything in it. That actually has some stuff. We can, but of course, we can execute expressions there. And then we also support doing this with PySpark. And with PySpark, you can give it nothing, or you can give it a specific warehouse, like my data warehouse, and that will use that directory named my data warehouse as the stream. And so, of course, you get a bunch of Java logging things, and you can hopefully execute that. Took a while, but that's how you do that with Spark. And then finally, we have SQLite, which is actually a populated database, and we can actually start to pull out some data here. Let's actually pull out batting. So we have our batting. Of course, then we can turn on, interactive true. Look at the first few rows. Cool. So we've got our SQLite database. So that's how you use ibis.connect. So we covered ClickHouse, DuckDB, Impala, MySQL, Postgres, PySpark, and SQLite. The remaining ones are Dask, Pandas, and DataFusion. And like I said in the stream where I was muted, so of course nobody heard that, Dask, Pandas, and DataFusion are not yet supported in ibis.connect, but we support the other 7 or 8 backends. So one thing that's kind of interesting is that there's another backend that sees a decent amount of use, which is the BigQuery backend. And of course, if we try to do that, if we try to connect to BigQuery, let's just try some stuff. This is IBIS-GBQ is a BigQuery project that we use for testing IBIS things. And let's just try to connect to that project. We got some kind of random error. Backend connect got unexpected keyword argument host. This is not a super great error message, but the way connect is implemented allows us to actually just kind of scratch our own itch and implement this ourselves. So let's do that. I'm going to quit out of this terminal session. I'm going to open up my editor and look at ibis backends base init, which I know is where the implementation for connect lives. And so connect is using something called a regex dispatcher, which will allow you to register functions that all share the same API. And what you're registering with them is a regular expression that, if matched, will call the function that it decorates. So in this case, we're decorating a function that, if it matches any of the existing backends minus these 3 backends, which we special case because they are file-based backends, will get the backend from IBIS, muck around with some stuff, add query parameters, and then call the backend implementation of the URL handling. And you might be wondering what these priority arguments are. They are a keyword argument to allow functions to disambiguate if two or more functions match. And they're sort of just ordinal numbers, like they don't they're like 12, doesn't really mean anything unless it's greater than some other number. So this particular value is not super important. And of course we don't have an implementation of connect for BigQuery, so let's implement it. Now ibis BigQuery is a separate Python package that I have installed in my environment. And ibis itself uses the entry points plugin mechanism to recognize that ibis BigQuery is actually an existing API that can be used. And so even though like if you wanted to use ibis BigQuery directly, you would say import ibis BigQuery, but because of the setup tools entry points integration, we can actually just say ibis BigQuery.connect like the rest of the backends. And so that's actually how we're going to implement this. So the way you implement this is you say connect register, and what we're going to do is say, okay, the URL starts with BigQuery, and then we have some stuff that we need to handle here. We already know we need to handle project ID, so I'm going to use the Python syntax for capturing a regex that is pretty much anything, and this will capture project ID, but we need to capture some notion of dataset ID, of course, which itself is, again, just pretty much anything. There are actual limits on what BigQuery allows, but for kind of time and simplicity's sake, I'm going to actually leave these as dot plus notation for now. And then we register a function. We call it underscore. It doesn't particularly matter what this is called. It can be easier to debug if you have an actual name, like if something goes wrong. And then the way connect invokes these functions is first with the entire match string, in case somehow that's useful to the function. So we're not going to use that here. So I'm just going to say underscore, give it a type, and kind of move on. And then if there's any match, or rather any name that is part of these named capture groups will get splatted into the call as a keyword argument. And so just to make sure that that's true, we actually use required keyword arguments here. And then we're going to do the same for dataset ID. And then this thing returns an instance of base backend. And now we had to fill this out. You might notice that there's actually a couple of things here that may need to be adjusted. One is that this dataset ID is entirely optional. I can just connect to a project, and then I can start mucking around I can start doing like list datasets, and then I can of course like set database, and that'll put me in the context of a particular dataset. So this whole thing, including the trailing slash, needs to be optional. I guess the semantics here are that if there's a trailing slash at all, that there needs to be some dataset ID. I suppose we could make the trailing slash itself optional, but again, I'm gonna not kind of address that complexity right now. So first off, we need to just import ibis, and then say ibis BigQuery connect project ID equals project ID, and then again we need to say dataset ID equals dataset ID, or empty quote. If this doesn't match, if this doesn't match, then dataset ID will be none, and then it turns out that connect needs some notion of dataset ID. It can be empty, but it will not accept a none value here. So I'm going to just format it so I can get rid of the lint errors, and let's try this out. Okay, actually, let's just go back into our environment here. We'll say import ibis, and then we'll try to connect to BigQuery. And we'll see, okay, like why are we still getting the same error message? And if you look at the implementation of what I did here, you'll notice that I'm using dot plus to match product ID. So let's see, why isn't this working? Well, we can always stick a breakpoint in there and see what things are coming in here. All right, Python, ibis. It looks like basically something isn't matching for whatever reason. So we need to kind of figure out what's going on. I didn't actually put a priority on this, and so there's another pattern that's matching before this one, and that is the one that that is this one here, and that is because get backend names again above uses setup entry points, so it's actually pulling BigQuery into there and then trying to call it with this thing here. But upstream, ibis BigQuery has not implemented from URL because it's a new feature and it hasn't been, it's like it's not available to ibis BigQuery yet because it depends on ibis, a slightly older version that hasn't been released. So we're going to need to special case BigQuery, which we thought we already did, but we need to set a priority higher than 12 so that if the BigQuery I want to implement here matches both of these, that it'll get preferred of the other one. So we could just set it to 13. Of course, now I need to format again, and let's see what happens now. Import ibis, connect to BigQuery. Well, it looks like we got something. So let's try and list our databases, which should give me data sets. Cool. And can I get out, let's set interactive to true. Can I get out a table? Let's say con dot, well, first we're going to need to set the database to what? Workflows. And then we're going to say con dot tables dot workflows dot con dot tables dot analysis. Let's use a smaller one, jobs. Okay, looks like something's happening. Great, we got some information. We got an annoying warning about temporal types and time zone conversions, so that's fun. But we were able to actually get out our data, and you can see we've got the URL column, etc., steps, completed at, and so forth. So we actually appeared to have actually successfully implemented a BigQuery thing. Let's see if we can just connect to a data set directly. Import ibis again. We did workflows. Okay, so we got some kind of bug here. It's like, well, it appeared to connect, but it didn't really, get us what we want. So of course, one thing you can look at is you can poke around in the connection, right, which is part of ibis BigQuery, and you can say, okay, well, what's the project ID? Okay, well, that doesn't look right? It's like it's got the project ID / workflow, so probably something is wrong in our regular expression that we're using. So let's look at that. So it looks like dot plus, which it looks like dot plus is capturing, basically everything, right? And that makes sense because dot plus is greedy and it's going to keep going until it matches nothing else, including if there are any subsequent matches. So one way to handle this is to say match not greedily. But what we really care about is just stopping at the first /, right? And so we can encode that as a logical negation saying, hey, I want you to match any character greedily unless it's a forward slash. Okay, let's try that and see if that works. Ibis. Okay, con project ID looks good. Dataset ID looks good. Let's list our tables. Cool. Let's look at con.tables.workflows. Let's set interactive to true. And then let's look at the first few rows. All right, sweet. Looks like we got the thing we care about. So we've got our columns. There's a lot. And we successfully implemented the ibis BigQuery implementation of ibis.connect. Thanks everyone for joining, and I'll see you next week where we are going to talk about some super interesting stuff with a colleague of mine, Saul Poinson, who develops the amazing visit data and how it can work together with ibis for maximum productivity.